Okay, so I think we can probably get started now. So good afternoon, everybody. Thanks very much for your time today. My name's Paul Brett. I'm responsible for Cubro's business in the UK, Ireland and Middle East. And I'm joined today by Fabian, actually, who's a member of our technical team.
Hello, welcome everybody. Yeah, Fabian, my name. I'm working the Cubro technical support team. I'm also as a solution engineer and product owner at Cubro.
Great. Thanks, Fabian. So, as I say, obviously, welcome to the webinar. And the focus of today is to talk about Cubro's bypass solutions and the benefits that they may offer to you and your organisations. So, in terms of agenda, I'll start in a second. I'll just tell you a little bit about Cubro and who we are for people that don't know. I'll just then summarise the benefits of our bypass solutions, but the meat and the majority of this session will be covered by Fabian. I'll hand over to Fabian at that point. He'll introduce you to the products, describe the product capabilities, and the different use cases and deployment options available to that technology. I'll then come back at the end and summarise, and we'll have Q&A at the end. Obviously, if you have any questions as we go, then please just put your hand up and we'll answer those as we go. I'll also just draw your attention to the right-hand side of your screen. You'll see there we will publish a number of polls and there'll be handouts available and so on from that part, from the various tabs there. And also we'll be publishing a survey during the Q&A session as well. So if we get started then, so who are Cubro? As I say, for those that don't know, we are a market-leading manufacturer and global supplier of network visibility solutions. Our products include network taps, packet brokers and aggregators, bypass switches, probing solutions, so metadata generation and optimization, and other technologies such as deep packet inspection. Our customers are really a who's who of service providers worldwide, actually, and then mid to large enterprises in both the private and the public sector. According to Omdia, we are number 5 by market share now globally, number 3 in EMEA, and number 2 in Asia Pacific. And actually, we expect that to increase over the next 12-18 months. One of the differentiators between Cubro and most of our major competitors is actually that we're a European company. We're headquartered in Vienna. The majority of our competitors are North American centric. We have offices in Japan, Singapore, Vienna, obviously, Graz, and the US. And the founders of the company are still actively involved in the operation of our organization. So we're a very fast-moving, very flexible organization. And we've been around now for over 20 years, so we have extensive experience in this marketplace. In terms of product range, our products fall into 4 broad categories. The first, working from left to right, the first one, we have a full range of taps, bypass switches and bypass taps, which would satisfy pretty much any environment that you may come across, from 10 megabit copper through to 400 gig fiber. We then have several ranges of network packet brokers and aggregators. Again, a wide range of performance capabilities, from low speed copper through to high speed, high performance 400 gig fiber. And we also can recognize and understand network traffic up to layer 7. So that means that we can make traffic optimization decisions according to application type and service type and so on. We then have a range of probing solutions which effectively generate and optimize metadata. And we address that in 2 sort of technology areas. We have, firstly, is the CDR generation and optimization. So we generate CDRs, we then optimize them, and then we push those out to the relevant receiving monitoring probe or data lake or whatever the receiving device is. And what we're seeing with that solution is that we can provide a traffic reduction of about a factor of about up to about 1,000 times compared to raw traffic. So if you had a 2.7 terabit user plane, for example, then the capacity of the monitoring device needs only be 2.7 gig. So very significant traffic reduction, whilst obviously saving all of the valuable data that needs to be monitored, but very significant traffic reductions, which translates into very significant capex and opex savings. The second technology area where we generate net flow and we optimize net flow as well. And there we can provide traffic reductions up to a factor of around about 85 times compared to native net flow. So that's not native raw traffic, it's native net flow. So compared to raw traffic, it's much more significant as well. The fourth product area is a range of software products that we have. So NetFlow Optimizer is one of those. We also have our deep packet inspection engine, which is forms a component of a number of our solutions. And then we have centralized management called Vitrum for all of our products. Actually, all of our products have graphical web GUIs, which are point and click, very easy to drive. But in some circumstances and some customers prefer centralized management, and we have that capability as well. So that's just a little bit about us and our product range. And I'll just have a couple of slides to very briefly summarize, I think, the benefits of our bypass solutions. So the first one, of course, is to improve network performance and the security posture of networks. And we do that by making sure that the tools, the monitoring, the security, the analytics tools are always available to manage the network. We have several products in our portfolio that cover both copper and fiber environments. Today, actually, we're going to focus and talk predominantly about our advanced optical bypass, which supports link speeds of up to 100 gig. Operationally, we help to improve business continuity because we remove the single points of failure in a network tool architecture. We can be deployed both inline and out of band, and in both environments, we're able to automatically detect when a network tool has gone out of service, steer the traffic to an alternative network tool or port. Then when the original tool comes back into service, we're able to steer the traffic back to that original device. In terms of the configuration of the network tools themselves, we can deploy in several different operational modes. So we can have a straight bypass, if you like, so that if the network tool fails, we can just bypass and just send the traffic down the link, if that's what's required. We can also deploy in a hot standby. So we have a primary network tool, and then we have a secondary network tool that's not operational, but is powered up. And in the event of the primary going out of service, that we steer the traffic to the hot standby. The third configuration option is to effectively have multiple operational tools where we load balance across those tools or across their ports, so that if one goes out of service, the others pick up the workload until it comes back into service as well. So a range of flexible solution deployment options, both inline and out of band, and how we can configure the links and the network tools. Following on from that, because of that business continuity capability, it also gives us more flexibility how you schedule network maintenance and upgrade times for network tools. Ordinarily, you would need to schedule network downtime, and that's normally in the middle of the night sometime, and probably at the weekend as well. Whereas, of course, with this type of capability, you're able to remove the tool, upgrade it, and reinstall it without it affecting the network service. So it gives you more flexibility around when you might want to schedule and carry out maintenance upgrades. So those are some of the technical and operational benefits. I have a couple really of commercial benefits that the products offer as well. So we can help to reduce the costs and help right size, both from a CapEx and an OpEx point of view, for the network tools themselves. And we can do that because we have an integrated network packet broker function within our advanced bypass solution. So we're able to filter out traffic that does not need to be analyzed by the network tool. We can aggregate traffic, and as I mentioned previously, we can load balance. And what that basically means is we can reduce the loading on those network tools, which means that we can reduce the capacity required, which translates into reduced CapEx and OpEx as well. The architecture of our product is such that actually we supply single unit bypass, which support up to 100 gig link speeds. And the reason I mentioned that is that, that's to contrast that with other approaches where what we don't do is have multiple bypass switches on a card that is then sits into a chassis in a high cost centralized chassis based system. So you can deploy a Cubro bypass per link. In fact, each of our bypass switches can support up to 4 individual links of speeds up to 10 gig and 25 gig, or a single link of speeds up to 100 gig as well. So what that all means in combination is that we have a smaller increments are required for investments to add bypass and business continuity to your network on a per link basis, rather than being forced because of product architecture to have to invest in bypass capability that may never be needed or is not needed for some time to come. And the last point here, broadly in terms of cost competitiveness, as with all Cubro products, we're very competitive on price, and we are typically 30 to 50% lower cost of ownership compared to our major competitors. Finally, we can also help you with investment protection. And what we mean by that is that we have a solution to help you and support you on your journey, your business continuity journey, whatever the environment might be or however it might change. So as I mentioned before, we have flexible solution deployment options. We can support multimedia types, copper and fiber, and a whole range of speeds as well. They're very easy to configure. So if your environment changes and you need to reconfigure and change the operation of the bypass switch, then you can do so pretty easily. And we can support multiple trigger options, and Fabian will talk a bit more about that. So whatever your environment is, whatever it changes and evolves over time, then we're able to support you in that business continuity journey throughout. So in summary, in terms of benefits, we offer a range of technical benefits, obviously operational benefits, scheduling benefits, cost benefits, as well as investment protection. And now I'll ask Fabian just to pick up from now, and we'll tell you a bit more in detail about the products and their capabilities and the use cases. And I'll join in again when we talk about the summary at the end. So Fabian, over to you.
Thank you very much, Paul. Thank you very much. I will start my screen. So hello everybody. Then it's easier. So you should see something. Perfect. And a little bit easier for everybody. So thank you, Paul, for the introduction of the platform. Yeah, let's speak a little bit closer to the EX400 platform and also the smaller bypass devices that we have on the portfolio. Oh, this is a pen, not a laser pointer. Yeah. So let's speak quickly about the EX400. How is it installed? How can it be used? What are the hardware options? Then we have two other bypass platforms. What are the differences? We can speak about the configuration, about the usability of the device, and some detailed deployment scenarios that are really coming from customers that we have worked out together. So we can go through that a little bit and see how things go on. So as Paul explained, why is a bypass installed, or what is a bypass therefore? So there are multiple options for high availability or redundant solutions. One of the problems is that definitely that if you have your network in a linear line and anything happens to one of the points, you have service downtime, you have it costs a lot of money, a lot of time, people don't have backups. It's frustrating. So therefore, I don't need to tell you probably, but redundant systems are very, very important. And bypass is one of the options. Hardware bypass is one of the options you can do to very simply avoid network downtime. So the problem is the high risk of service failures, inflexible routing, lack of visibility, and more. I would say also that when you want to maintain anything, you want to be flexible in terms of vendor differentiation. Then external bypass switch has a lot of benefits compared to redundant systems in a classical form. You have monitoring capabilities, and it comes in place that Cubro is as a hard vendor for network packet brokers. So we are combining bypass hardware and network packet broker experience to have a bypass that is able to filter and load balance. That's what Paul mentioned before. So the combination gives you flexibility in rerouting traffic, in avoiding service downtime, in doing maintenance work, and still you have visibility and monitoring purpose to use the EX400 platform. So this is a very unique product on the market. When we're closer looking at, when we see here, the bypass is now high level installed in such a network, and when the same issue happens as before, we are monitoring the services with heartbeat packets, so to check if the service is working correctly, and when a downtime is detected of such a service, heartbeat fails, and the X400 is excluding this service, this tool from the network. So we have decreased maintenance, extended life cycle, and a quick return of investment of the bypass when you just save costs of the service downtimes. So a lot of features are supported in the bypass. As we said, it's a packet broker plus bypass combination, meaning we have, of course, all the filter capabilities. We have the self-generating heartbeats that are modified, that can be customizable on the UI to match the requirements. You're available in single mode, multi-mode, speed from 1 gigabit to 100 gigabit. We support two X400s in a 19-inch rack space with one U height. So there's a rack mount kit included that you can install two bypass X400 devices in one U into the rack. We have a combination of software bypass and hardware bypass mechanism in the architecture, meaning software bypassing for very quick routing time, meaning downtime is something between 25 and 50 milliseconds at the least. And the hardware bypass is there for critical downtime of the device itself, to have for power outages also of the X400, to ensure that the downtime is as less as possible, and there is always a backup system available. Link close carry function for the link, and web UI, which we come close, is very simple to use and very simple to start up, also for non-technical people. So let's have a closer look on the hardware itself. This is how it looks. It's, as we said, half 19-inch, and with a rack mount kit included, you can install two of them into one U. We're on the left side, we have the QSFP cages, so the QS1 and QS2 port, where you can insert any kind of QSFP, 40 gig or 100 gig transceiver, multi-mode, single mode, whatever is available. And on the right side, port 3 and 4, these are the optical connectors. So no QSFP required here. These interfaces work also when the device is without power, so that the link connected here is always established, even if the power outage is there. When we look at this again, we have the X400 in 3 different options, meaning we have it in multi-mode with SR4 connectors, as you see here. The same connectors are available in single mode, PSM4, and a connector for LR4 single mode is also supported. So there are 3 different device types, 3 different articles, product codes. These are not changeable after the order or after the delivery. This is done in the factory already, so there's not module-based replacement possible. But the combination of here on the right side, the fixed network connectors, and on the left side, the QSFP, provide a wide range of flexibility. Each port can be configured in the 25 and 10 gigabit interface. Paul said it already, and it's stated here. So the device can be used in one time 100 gig, or you can use it as 4 times 25 or 10 gigabit 10 gigabit link network bypass. So using a breakout cable or a breakout box, you can support 4 links of 10 gig in one X400 device. There are multiple use cases. Then later slides we can have a look at. A quick look at the other devices that we have. We have a smaller chassis, we call it small bypass. It's available in copper, and is optical bypass. These are for, as I said, 1 gigabit installations for copper, having about the same functionalities without the heartbeat function. So this bypass is there for smaller use cases, for simpler use cases, or in combination with a Cubro packet broker, meaning you have a bunch of links, and you want to insert certain tools, or also using for monitoring. Then a Cubro packet broker can be added to terminate the bypass traffic and then route it to the firewall IDS systems. Same is now for the optical bypass. You see here, this is also available in single mode and multi-mode, and this would also support up to 100 gigabit in the single mode version, because it's just an optical fiber cables installed, and the software is basically just redirecting the traffic to the device side or the link side. These are also 1U in height, but they are a third 19-inch, so you can install 3 of these devices in a rack in 1U space. Good, let's look at some of the deployments. So very simple, how would be installed? You connect the live link on port 3 and 4. These are here in this diagram 2 routers that are connected to each other, and the goal is that the traffic is going through this DDoS application to remove DDoS attacks, or do any other certain kind of traffic investigations here. If the DDoS appliance would fail without a bypass, then the connection between the routers is disconnected. The X400 here allows to have the protection, meaning the traffic would now, in the working condition, come in here, would be directed to the port 1, goes here, and then the good traffic passes to the port 2 and then redirected to 4, going back into the link. If the DDoS application is not working, if the heartbeat fails or any other trigger condition triggers, then the software bypass or hardware bypass is triggered and directly connects these 2 devices to each other. This is a very simple bypass usage here. The very spectacular thing from my perspective on the X400 is the very simple configuration and installation of the device. So when you receive the device, also as a non-technical person, you are able to set it up. You boot the device once. Of course, you do the basic configuration of the device, like user management. Maybe you do quickly an updates when it's a little bit older already. You set the IP settings, but then you come to the cool part. You start to select one of the scenarios. So all you need to do is you start this wizard of installation, and it guides you through this wide range of use cases that are applicable. So you can define how many appliances do I need to bypass. Before, in this scenario, we saw 1 only, the DDoS application. We support up to 4 inline appliances. And depending on your choice here, you're getting already predefined use cases here, and you just select that one that matches the use case why you have purchased the EX400. The last step already is just to choose a trigger. So as we said, we have the keep alive with heartbeat packets. So inline heartbeat packets are added to the connection to the tool. If the tool doesn't resend the heartbeat packets, then we can assume the tool is defective. We have parallel to that rest keep alive. So this works over the management to do heartbeats via management, or just a regular ping via ICMP. It's also supported, also working via the management interface. And all these triggers are supported by every scenario that you saw before. So there's each combination, of course, is supported. And that's it already. So you finished, you get an confirmation, you press, and then the device is already functional and working. More you don't need to do. You don't need to define rules. You don't need to define a traffic flow. You just select the scenario. To help you selecting the right scenario, each scenario offers a link to a video, and you can look the video directly on the pop-up then, and it shows you how the traffic flow would be for that use case. So we have here the use case that we have one link, but we have two inline appliances, meaning that one is the primary device where the traffic is going to, and we have a standby device that once this device is down, we have the standby device. So that the link is always going through one of these devices that can be parallel configured. And on this video, the videos are all available on YouTube. If you want to, you just hit Cubro Network Visibility on YouTube, and you can go to the channel, and there you can you can watch the videos there, and you can see that here the cabling is done as it would be in a real life scenario. You have the main tool and the backup tool that would be represented this, and the two live devices, and then there's a nice animation that shows the traffic flow for the working condition and for the bypass condition. Here we have the graphical dashboard. I will maybe skip for the moment because we later jump quickly on the web UI and have a live experience of it. Yeah, but you clearly see here that the indication when something goes wrong, when something is down, that we have here this graphical status is always representing the status of the device. So it's clearly seeing that something is not working. So let's quickly speak a little bit about the different deployment scenarios that it has. So first we have this 4 independent bypass scenario where you have 4 links, for 10 gig links or for 25 gig links, and then for each link there's one inline tool working. So these are really 4 completely independent links with 4 appliances in place. So we're working here via the channel options of the connector. This is maybe more applicable to the multi-mode SR4 and single mode PSM4 variant, because for LR4 the channels is not really applicable, a little bit more tricky is possible but not so clear. Here this is with the MPO connector, it's easier, and with breakout cables or breakout boxes you can achieve this connection here. The cool thing is, of course, that you can here reinsert the traffic from one link to the other, meaning that the traffic just passes multiple times through the X400, and each individual tool can be bypassed during the other 3 or other 2 still working nicely. So independent software switching also. Then if maybe these 4 links only have one appliance in place, then we have this scenario. So all the links getting feed through the same device. We have one heartbeat to check here. Maybe going back here, we have, of course, 4 independent heartbeat flows. So 4 independent heartbeats checks and 4 independent bypasses then. And here we just have one. So this could be a firewall for these 4 links. The same is for this 100 gig link, as we said before, 100 gig link. Then we have 2 appliances here, primary and backup, and hot standby with, again, 4 links here, also 2 appliances as hot and standby. And 2 scenarios for load balancing. So we have, again, 2 appliances, but instead of just sending it to one tool at a time, we can share the load to both of them. Of course, if one of them is failing, all the traffic goes to one only. There's also a scenario, it's not in the presentation, but of course that you have a link here, 4 link or 1 link. And then all these ports here in split mode can also be used for load balancing, meaning up to 8 ports available for load balancing. Also, this mode is available. In parallel to all these flows and to the scenario, you have the option, so it's not mandatory, you have the option to configure flows and rules like in a classical packet broker. So you can overrule specific standard flows by filtering an IP address or protocol or whatever. So you can add your own customization by flows. If you know what you want, you can add something there and it will be applied into the scenario. As I said, completely optional. Good. We will have a look at this on the UI. Let's quickly now go into some real use cases, some scenarios that we have worked out with somebody in the past. And quick looking in the chat if there are any questions. No questions. So here we have one scenario from a small service operator. This we have applied on 2 data centers. So you see here you have a small number of links. This was 2 links in a load balancing group. And the goal was to apply a DPI blocking mechanism in there. This DPI engine is inline in the network. And in parallel, we have a monitoring system connected. So these are sensors for monitoring. So the goal is that we pass the traffic to the DPI engine, then pass it back, and providing a copy of the data to the sensors. Here we have in the middle a Cubro Session Master EXA32100 in place, so a 32 100 gig port packet broker. And on the top level, we have EX400s that are directly there for bypassing the whole system here. So this was a requirement that this whole system can be bypassed by this 2 EX400. We have 2 because we have 2 links here also. Then the traffic is here. It can be copied and sent to the monitoring system. And then in parallel, it's fed to the DPI engine. Also, the DPI engine is connected via 2 times 100 gig actually, but each of these links is bidirectional here now, of course. So we are going in with 1 link and the bypasses here again, ensuring that the connection to the DPI is working. They have a heartbeat mechanism here, so the traffic can flow like that, or it's the DPI engine is down and then it's bypassed. So this is a completely high available solution. This here can be optional, so you can of course directly connect the links here. Sorry, of course, this is optional. Sorry, these are optional. These are of course required if something breaks. But the thing was that the monitoring system should still be available even if the DPI engine is not there. So we have these 2 stages of bypasses included. And here you also see that the link is actually single mode LR4, but all the connection down here is with multi-mode. So here you can use the cheaper transceivers, but on the live link they having these LR4 transceivers. Use case from an enterprise customer, from a normal IT network. They had the requirement, they had multiple interfaces in the network, and this should be running through an IDS system to measure any threats and certainly block it. And they said cool would be NetFlow from this here, because the system itself does not support NetFlow, but they would like to do it. And so they had two use cases in once. We are installing two X400s here because we have 1, 2, 3, 4, 8, 10 gigabit links. So we exactly need two X400s, one breakout box here converting the 10 gig signal to a 40 gig signal. Then we have here the links to an Omnia 120 packet broker that is collecting all the traffic from the network and then sending to two IDS system, or IPS here it's called, to them, and in parallel doing NetFlow here on the different links. And the option was here for tunnel encapsulation, decapsulation. I think this was not used then in the end, just a NetFlow option here. And of course, some filtering can also be done here on the X100 level or on the Omnia. You can filter on many different things here. Looking at the time, okay. We have a joint solution with Fortinet as well. So we have many discussions in US and also in Europe made, and we found out that especially with installations of Fortinet, they're very advanced firewalls, of course, but some generations have the problem that updating was very difficult. So to upgrade the firmware of the devices, you have a high availability option there, but still some stuff need to be taken down before the other service comes up. So upgrading and maintenance was always combined with service interruption. And we spoke with a lot of these warehouses then, and the X400 here was the optimal option to have the traffic load balanced or used in a hot standby scenario to include the bypass here, and just having the option to the flexibility to route the traffic to the Fortinet device that they actually now want to use, and so take the traffic away from another Fortinet. And this is true now for not only for Fortinet, but for a lot of firewall vendors. It's just good to have another vendor in place, a independent socket where you can rely on to route the traffic in case something is not working. So of course you can also use here the monitoring perspective. You can copy the traffic out somewhere. You don't need to insert another tapping maybe, so you can just take the traffic somewhere else. So it's a good party to have it in network, especially if it's very important that the traffic is always on. No questions. Okay. Then we have one very specific use case. So this is not now a real deployment, but this was discussed very far. To be very transparent with you, discussed very far. Inline load balancing for certain use cases very important, but always this has a very big problem with high availability. And here we come up with a solution now to have an high available load balancing cluster to have these free servers load balancing the traffic to several 10 gigabit connections. There's a question from Rick. Fabian mentioned the DDoS application from a security aspect. Can you tell something about the security features from the bypass? So the security features from the bypass are clearly that you can have the filtering. Filtering, you can specifically say every encrypted or unencrypted traffic should be forwarded, meaning by protocol, you can filter it out. Of course, you have the heartbeat mechanism to ensure that certain services are really working. This is a security aspect to verify that the services are working. This is my point of view. And itself, of course, the bypass is locked with user management and everything. So it's not something that you can go there and SSO or pen testing. Yeah, the device is complying to our software regulations. So the software is like for all other packet brokers is pen tested. We do regular scans and updates on it. The software itself is a little bit more basic compared to bigger devices. So there is not running a real Linux on it. So it's much more an embedded system. So offers already much less functionalities than the other packet brokers on the Unix shell. Even the Unix shell is already hidden there, so it's not like you can access device and have root access already. So no, so it's definitely on the same level as other devices where we have already done pen tests with other customers. Question from Mike: do the bypass tab support both positive and negative heartbeat packets? Once that must be through to attack device and once that must not get through the provide filter. So actually no, we only have I would say positive heartbeat packets. Packets are sent out and we are expecting them to come back. But if you have a very specific use case, I'm happy to talk with you after the meeting. Maybe you can explain a little bit better by email about the use case, and this can be edited. So it's nothing, no problematic. Currently, only the positive heartbeat, if I'm understanding you correct. So here, as I said, thank you. For inline load balancing from 40 gig to 10 gig was a requirement, and then it's a problem about the high availability. And here the X400 is used in a little bit different concept. So here it's more like, when I go to the next slide, it's here now this part here, and this part here is explained a little bit deeper. So you come in, you can have the traffic. Of the one hand, if traffic comes in, we can duplicate the traffic and then going out to the load balancer. And on the back direction is that the traffic can only comes in on 2 ports, but is primarily only taken from 1 port. The other traffic inserting is just discarded. So you're avoiding that you make doubled the traffic. If the X400 fails or the load balancer has a problem, all bypasses switch parallel to the backup link, and then the traffic is taken here from the P2 to P1. So all bypasses can work in parallel then they always have the same status. If the load balancer fails or any of the X400 fails, then you have this bypassing mechanism that just to take the traffic from the backup load balancer. Of course, one load balancer always needs to work that this functionality is, but yeah, single point of failure here is avoided. What is the port-to-port latency at 100 gig? Don't put me down on the number. You can read it in the data sheet on Cubro.com, but I think it's something like 700 nanoseconds or something. I think 700 nanoseconds, but for a specific number, you can look at the data sheet. Yes, a quick, what's the time? Okay, here is a use case of the small bypass in combination with a Cubro packet broker. Here it says Packet Master EX2, EX52. It's actually EX53. It's the new model is called. It's just a little bit older picture, to be honest. So sorry about that. But you see here a connection how a copper bypass can be used very simply. The more management and heartbeat functionality, the packet broker would take over, because this simpler bypass is only there to detect, or let's say to have one status of forwarding traffic to the inline tool. If the packet broker gives a command to switch, then this device will switch into the other status and then just send the traffic there. So this switch is for more simpler use cases and cannot really monitor the status of the inline service. It can do it by ping and API, but not inline like the X400 can do. Good. Let me quickly use the last few minutes to jump to the web UI of the EX400. Make it a little bit bigger. Not too big, so like this. Hope you can see everything. As you see here, this would be the dashboard. I'm now connecting to the device. It's working live. I see here on the left side the scenario. I see what trigger I have selected. So my hot standby, as you see, I have only 100 gigabit links using heartbeat packets, and the bypass status is off. The bypass itself is off, but I see that one of the ports here of my backup tool is down here. The port is down. That's why the connection to the backup tool is not working. Of course, the heartbeat cannot be detected if the port is down, but the traffic to the main tool is actually working. So there's no problem itself, but I should maybe have a look on the backup appliance why it's not working. I can explain this. I have my system here. I can reactivate this. So I'm here. I have connected something here. I'm activating the port now. And as you see now, the port is going up, and now the check to backup is working perfectly fine. I can also simulate a failure of the main device by just changing a rule on my other packet broker. So it's not the X400 itself. I just change it here on another packet broker and disable the traffic here. And then, of course, then the port itself stays up. So there is no layer 1 problem, but the service here stopped working and the heartbeat is not rerouted anymore. And now the traffic is sent to the backup appliance. And it says here, bypass is off, because here, this would be the bypass, because it's off, but the backup appliance is in use. We can simulate also now that also the backup appliance fails. What about that scenario? Of course, single point of failure, one device should always work, but in case both is not working, then you have the real bypass here enabled. The traffic is redirected here. Both devices are down and the traffic is here redirected. Then this would look like that. It's still using the software bypass, so the traffic is still handled not software based, but by configuration of the device, and the hardware bypass is not enabled. So the switching here would still be about 25 to 50 milliseconds. Depends on reaction or the configuration of the heartbeat, and also the detection then of the link here. Of course, if the service has any other problem before and then drops the heartbeat later, it can happen a little bit longer. But when the heartbeat is detected to be failed, the switching is within 25 milliseconds about. So if I revert this now, first revert the backup. This works. Give me a second. I don't change anything on the X400. I have not changed anything here. I recovered now that, and automatically the device is coming back to life. There are a lot of configurations possible, so you can disabling auto synchronization, meaning that when the device is once in bypass mode and the device is coming back to life, that it doesn't automatically switch back. This is configurable. You can configure the mechanism or the logic stay on the backup device if main is down or not. So there is a lot of configuration possible, but it's optional. So to a little bit customize your own use case. The big thing I wanted to show you now is the maintenance mode. So per default, I cannot do anything. I have no possibility to change here anything. But if I now say I want to maintain this device or I want to swap something, I just want to take the traffic off and send to backup without having an issue. Then I can go to maintenance mode here, turn maintenance mode on. Yes. Now the device is not switching automatically anymore. So heartbeat is now disabled and it would not switch automatically. Now I can manually say use backup appliance. The traffic swaps to the backup appliance here. And now I can take the main device offline. I can update it. I can replace the cable. I can do here on the port something to change, whatever. And once I say I want to revert the traffic now, I can do that here. I can check if everything is working. If not, I can directly go back, it's no problem. But you can route the traffic there, check if if the things are working as you expect. And then if everything is good, you leave maintenance mode, the automatic heartbeat is coming back, and then the devices are monitored again. Good. We are about to close the session and leave some words now to Paul, and then we can do some Q&A if there are any questions left.
Okay, thanks, Fabian. So let me just, I guess, just in way of summary, hopefully that's been useful content and useful information. But by way of summary, I guess the key point, obviously, for this technology is to help you improve your network performance and security posture. That's the key objective. And we can do that by improving business continuity because we can remove single points of failure in your network tool architecture, which also then, of course, it helps with easier scheduling for maintenance and upgrades and basically taking tools out of service. And again, then commercially, we can help you to reduce the cost of the tools and right size sort of CapEx and OpEx of network tools. Something I'll just mention in terms of price. I mean, a list price, our advanced bypass is around about it's about 25k euros for a unit, and of course that will support up to 4 links. So you'll be looking at somewhere around probably about 5k per link. Cost. But if you compare that to those sort of board chassis board type approaches, then the spend then is going to be somewhere in the order of north of 100k probably, and that's pound sterling, so probably about that 120,000 euros mark. So and that's really just to illustrate the difference in terms of the smaller incremental costs to deploy business continuity, protect your network performance and security posture on a per link basis. And then final point, obviously through investment protection, because we have a range of technologies, a range of products and a range of deployment options, I think then added in with the integral network packet broker capability, whatever your bypass or business continuity journey is, then we have a solution to help you with that, I think. So that's as far as I guess the summary was concerned. We were going to move to Q&A now. We've had a few questions, so thank you very much for that. It's always helpful. Are there any other questions? And I think also that Taman had also issued the feedback form. We'd really appreciate any feedback that you have for us for future webinars and so on. So I think that's everything from us. Just want to see if you have any questions now that we can answer for you. Okay, so I guess we probably answered everything.
Yeah, thank you for the questions during the meeting already. Yeah.
Yeah, and obviously, if you have any after the event, just let us know. Send us an email or some form of communication, and we'll get back to you and answer the question for you. So I think if there's nothing else to cover, we'll close at this point. And thank you once again for your time. Hopefully, it's been useful for you. And if you have any questions that come up or you need any additional information, just let us know. Thanks a lot.
Thank you very much.